The next reaction that we use to prep of alcohol is Grignard Reagent. A little bit about this person. So he's a French chemist. So I'm not gonna say his name. I don't know how to say it. So his name. So people call him Victor Grignard. Right. So he got Nobel Prize in 1912 from the discovery of the Grignard reagents. And by the way, when you say this word, so use silent G. So you kind of say like Grin, like green, and add Y after N. So Grignard reagent. That's how they call him. Okay. Don't ask me how to say his name exactly. Some of you, if you can speak French, you know, but I don't speak French. Look at my face, man. Let's see. So to make a Grignard, so I'll tell you why it's special in a bit. All right. So to make Grignard, so we start with an alkyl halide. Just add magnesium in either it's just a solvent. So you're gonna prepare R, which is an alkyl group, MgX. That's a Grignard reagent. Okay. What does it do? Is another reaction, and probably the maybe one more, but yeah, another reaction that add carbon chain to carbon chain. The first reaction that add carbon chain to carbon chain, you learn it in alkyne. So we have an alkyne and extend the chain of alkyne. That's one time. This is another one. To form a carbon-carbon single bond is really, really difficult because carbon-carbon bond is really strong. And this reagent can do it just that easy. So that's really important reaction. All right, let's start with how to make Grignard first. Okay, so we start with alkyl halide, add magnesium. So magnesium will insert itself between carbon and chlorine through the single electron transfer process, but we don't talk about it. So if you look at the electronegativity between carbon and magnesium, so carbon is much more electronegative than magnesium. We can treat this bond as an ionic bond. Okay, then this carbon is highly nucleophilic. Super strong base. If you remember, this is the strongest base in the pKa table. And you can make a Grignard reagent not just from the just regular carbon chain. You can make on a double bond too. That's really special, right? So so this is the benzyl bromide, phenyl bromide. So bromobenzene. Add magnesium in between carbon and bromine, so you get right there. The nucleophilic center is that carbon right there. All right, so we treat this carbon as a highly nucleophilic center. And you can also do with the allylic, we have allylic Grignard, so carbon right there, that's nucleophile, vinylic Grignard. So you can do Grignard in any way. So it's really widespread, a lot application that you can do with the Grignard. Okay, all right, let's see how this is how we use Grignard. So Grignard reagent allows you to add a carbon chain to a carbon chain. So you add the alkyl group to this carbon here. Right, so aldehyde, you get secondary alcohol. You get ketone, you make a tertiary alcohol. Okay, and the mechanism goes like this. Let's say I have an acetaldehyde. So this guy we call acetaldehyde. I'm going to add a benzene ring onto this guy. So I have to make an phenyl magnesium bromide. Okay, and then quench with water. We'll talk about this in a bit. All right, so the mechanism of the Grignard reagent is awfully look a lot like the Aldehyde and sodium borohydride. Let's take a look. So nucleophilic attack on the carbonyl-carbon. So you get a negative charge on oxygen, so it is oxide. And then we're going to add water to quench or work up to gain the product back, so to neutralize the product basically. So this is an alkoxide, not a product yet. So we have to protonate it, and also to destroy the leftover Grignard reagent because we add excess. Okay, we always add excess. One of them going to be limiting reagent, which is this guy. All right. So for the ester, again, the mechanism look awfully a lot like the LAH. In the LAH, you can react with ester twice. Same thing with Grignard. So we're going to add two equivalent on it. So you get two alkyl groups on it, right? If this were to be an LAH, the two alkyl groups here would be two hydrogens, right? Let's see what we got. We're going to add vinylic magnesium bromide, two equivalent onto this ester. The first step, nucleophilic attack. You got an oxide right here, so reform the double bond and kick out the alcohol group, the alkoxide group down here. So you get a ketone, right? But think about this: ketone is made in the reaction, which have magnesium bromide floating around. The Grignard reagent is still floating around, And this guy can be reduced one more time. So magnesium bromide will attack one more time. So you get this guy, and then we're going to add water or acid to protonate the oxide. Ta-da, we get the product. All right. So again, look just at the concept is just the same as the LAH. When you have a sodium borohydride or LAH attack the carbonyl is flat. Trigonal planar can approach the nucleophile can approach from the top, from the bottom. The same with Grignard, you can do either way. Right? This carbonyl is pro-chiral, so it's not a chiral yet, but after nucleophilic attack, it becomes chiral center. Right? Let's take a look here. So again, same mechanism. So you still use the phenyl magnesium bromide. Right? So this guy attack from the back. So this is backside attack, and the oxide gonna be point toward you, point to the front. The magnesium bromide can also attack to the from the front side attack, push oxide backwards. So go to that dashed line, and then you add water or acid, either way. So you get two products here. All right. Okay. New segment of our podcast, same thing, a Tinder date. So let's see the conversation on this Tinder. What are they talking about? So are we married now? Is that how this works? Yeah, me, you, my roommate Lindsay, who you send the exact same message to. Ha ha ha. That's the first time that happened. Oh man. Send a text to too many people. Okay, let's talk about how to use Grignard in an alcohol synthesis.